Hello all, in the previous video we discussed about static methods in Java. In this video we will talk about static variables. Okay. So just adding few more points to the static methods which we have already discussed. So we all know that static methods can't use instance variables. Okay. Static inside the static method implementation you should not use the instance variable because static methods gets invoked using the class name. Okay, you invoke it directly with the class name, and when you try to use instance variables, it doesn't know which instance variable to use. That was the reason why we should not use instance variables inside the static method. And one more thing is, you should not use non-static methods also inside the static methods. So let's say here playoff is a non-static method. If I try to invoke playoff method from print random string, which is a static method, it will throw error because we all know that this particular print random string of gets invoked using the class name, and this playoff is a non-static method, and inside the non-static method you might have behavior which is dependent on the instance variables, which is dependent on the state of the object. Now here let's say if you try to invoke playoff, then inside this playoff it is dependent on the title or instance variable title. Now I'm just trying to invoke using the class name song.print random string of, and now you are invoking playoff from here, and it is dependent on the title, which title it should pick it up. So there could be many instances on the heap, song instances on the heap, and it doesn't know which instance title it should pick it up. Okay, so this is the ambiguity that will arise if you try to invoke non-static methods inside the static method. Okay, so inside the static method you can't use non-static instance variables, and inside the static methods you can't use non-static methods as well. So sometimes, okay, there can be behavior something like that, something like this, like so this particular statement is not dependent on the instance variables or state of this particular object. Then we might get a doubt that now this playoff method is not dependent. Okay, then why is still Java not allowing? Now this at this particular point of time it is not dependent. Okay, in future programmers can do something like this, or they might add more code related which is dependent on these instance variables or state of this particular song object. Okay, so in that case it will throw error. So that's why, and as we already discussed, though the methods are not dependent, though sometimes you don't declare the method as a static, but still your methods might not be dependent on the state of the object. But Java doesn't care whether the implementation inside the method is dependent or not. It just looks for the static keyword. It just looks whether the static is present here or not, because in future people might change. Now it might not be using the instance variable, but in future programmers might change adding instance variables here. So to avoid this, you can't use non-static methods inside the static methods. Okay. And one more thing, so let's say here from the main of what we are doing song.print random string of. So I can invoke print random string using the instance as well, reference variable as well. Here I have created one song object, song s1, and then I can do print random string of. It will not throw error. Okay, it will not throw error because though you invoke using an object this print random string, its behavior will not vary. Okay, since it's a static method, it's advised to use directly with the class name, not with the instance. Okay, so because just because the Java is not throwing error, you're not supposed to use that. Though you do like this. Okay, s1.print random string, when the Java compiles and runs the program, internally what it does is it will convert this song s1 to song. Internally Java does something like that. Okay, Java replaces s1 with the song because this is a static method, and it will find what is the class name of this s1 reference variable. Song is the class name. Internally it will replace it. Okay, just because it's not throwing error, you shouldn't do that. Okay. Yeah, this is about the static methods. And now coming to the static variables. What are all the static variables? Let's see with an example. Okay, now you have a duck class. Okay, duck class. Now inside the duck class you have declared the size of the duck. Okay, you have declared the size of the duck. Now I get a requirement. Okay, I want to know how many duck instances I am creating. Okay, how many duck objects I am creating. I want to know the count. Then the first thing that comes to our mind is, okay, I'll declare a variable called duck count of. While creating an object, people call a constructor. Okay, they use this new duck of inside it. Whenever you want to create some instance, you use the constructor, right? New duck of. Since the constructor gets invoked, I will put duck count of. Okay, so every time, like duck1, for the first time when the duck1 gets created, this duck constructor gets called. Okay, and next time when someone is creating the duck, then also this constructor will get invoked. So I assume that every time this duck count of gets increased, and I can take this variable duck count to know the count of the duck objects that got created. But that is wrong. Okay, we'll see how. We'll see. Now here I have created two objects. Ideally duck count should print 2, right? Now if you look, system.out.println of duck1.count, duck1.duck count, it would be just 1. So if you see the value duck count, it's 1. And let's try with this duck2. Okay. It also gives you 1. Why is this happening? Because if you see, this is an instance variable. Okay. So whenever, let's say you don't declare this. This is an instance variable. And we all know instance variables gets initialized during object creation. We already discussed that in the constructor concept. Okay, now when you are creating first duck instance, what it does, it will go and check all the instance variables. Though you don't specify here, all these variables gets the default values. If it is an integer, it gets 0. If it is a boolean, it will get true or false. It depends on the type of the data type. If it's a reference variable, it gets null as the initial default value, right? Now when you are creating duck for the first time, these are the instance variables and these gets initialized to 0 0. Okay, 0 0. And when you are incrementing duck count plus of, it will 0 plus 1. So it will increment it and 0 plus 1. Now when you create duck for the second time, what you assume is, okay, it's already 1. Now if I do duck count plus, then it should be 2. But that will not happen. When you are creating duck object for the second time, then it will come here, and since these are the object variables, these gets initialized again. Because these whatever the variables here you have, these are per object, not per class. Okay, for each and every object it will have its own copy of size and duck count. It will have its own value. These values varies from one object to another object, and whatever the value that are present in size and duck count of duck1 can't be viewed by the duck2. Okay, now if I try to, let's say, if I try to invoke this duck2.duck count of, it will give the value that is stored inside the duck2 object. It will not give the value that is stored inside the duck1 object. Okay, so these values are, it will per instance, okay, per object. These are not shared across the objects. So whenever you try to increment it, it will initially the value would be 0 and it will increment it. Okay, it will increment to 1. It will not remember, okay, duck1 has already incremented 1 to 1, and now I'll increment it, I'll increment the value 1 plus 1 equal to 2. It will not do that. Okay, because whenever you're creating the object, these gets a fresh values, fresh start default values, and you start from there. because the whatever these variables are per instance or per object. Okay, so this will not work. Now what is the solution if I want to get the how many duck instances were created? Okay, then in this case what you can do is, okay, let's say I put something like this, new duck count of, okay, a new duck count of equal to 0, and now here I have created duck 1, right? Here I have created first object, I can put duck 1 duck count plus plus, and here I have created duck count plus plus, something like that I can do. Okay, but this code looks messy. Okay, you can have separate logic when, like, this is not the only place where you are creating duck instances. There can be other places also where you might be creating duck instance. Okay, so it's difficult to manage. You create your own variable, and wherever the duck objects are getting created, you are incrementing it, so it's difficult to manage. So to avoid this problem, or Java provides a solution for these kind of scenarios where a variable has to be visible to all instances, and that state should be same for all instances. Like, even if I modify the state of one, even if I, like, let's say here duck count, okay, initially let's say first object gets created and you increment it to 1, and next time when the second object gets created, second object should be able to modify it. Okay, it should modify it to 2, and the first object should be able to view this state. Okay, where the state of a variable should be modified by all instances, and it should be viewed by all instances, and it should be same across all instances. You should have something like that. Okay, that's where Java comes to rescue, and it will for a variable to work like that, Java says instead of using the variable as is, you just specify static keyword before that variable. Then in this case, it's not that each instance will not have copy of this. Whatever the value that is present in this duck count of will be viewed across all instances, and it is shared across all instances. Okay, so if you add static, this is not an instance variable anymore, this is a class variable. Okay, if you say instance variable, then each duck will have its own size, each duck object will have its own size. But if you see the duck count, each duck will not have its own duck count. This particular class has duck count. Okay, this particular class, for this class how many objects got created. Okay, this is a class level variable, not the object level variable or an instance variable. Okay, so for the variable to convert from instance variable to the static class variable, you have to add the static keyword. In this case, now you will achieve the scenario whatever you wanted. Okay, now you wanted the duck count, right? Now if you see, I can use duck2.duck count of as well. Now let's see what is the count. If you see, this is the 2. Now you have created 2 objects and it's giving you 2. Let me create one more object, duck3, new duck of. Okay, now let's see what is the duck count. It's giving 3. If I use duck1.duck count of, also it's 3. Okay, if I use duck3.duck count, also it's 3. See, it's 3. But ideally, if it's a static variable, you should not use the objects. Okay, you should not use this reference variables. You should use the class name duck.duck count, because this duck count is not residing inside this duck object. Okay, let me explain with an example. Usually, let's say you have one object. Okay, you have duck object. Inside this you will have variables, maybe duck count, something like this. Size, this is the duck object, you will have size inside each. Now whatever the duck count you have, right, it will have something like this on the heap per class. Like, this is a duck class, you assume that this is a duck class, and inside this it will have the count. Now this duck object can access this duck object can access this, and if you have one more object, this duck object also can access this. This is not residing inside the object, unlike size variable. If you look at the size variable, it is residing inside the object. So the value of size varies for each object, okay. But if you see the duck count, it is a shared variable, okay. Each duck object can modify it, and if let's say this duck object modified the value, then this updated value can be viewed by this, okay. If this modifies the value, it will affect all the duck objects as well, okay. This is a shared variable, this is a class variable. Now here if you see this duck, that's why since this variable, static variable, is not refined to any of the object, that's why you should call using the class name. Now you remember, right, inside the inside the static method, you can call static method using the object as well, like s1 dot, inside the main we saw, right, s1 dot random print random string as well. Just that Java is not throwing error, you are not supposed to do that, because this method is a static method and it should be called using the class name. Even if you don't do that, even if you use s1 of, it will replace with the class name internally by Java. The same case here as well, okay. This is a static variable, you should call, this is shared, like you can directly call this variable using the class name. Though you call using the duck1 dot duck count, duck2 dot duck count, it gives you the same value, but you are not supposed to do that. It's not a good practice, okay. This is the static variable concept, okay. Hope you understood it. Now let me share another example, okay. Let's say you can have the student class as well. Usually and each student has its own name, they might have the roll number, something like that, okay. Each student they can have their own height. But let's say you want to find the number of students in a class, you might get that a scenario, right, where you want to get the number of students. In that case, if you declare int number of students, then it will give you one value, okay. It will just give you the one value if you don't use static. But if you can use the static and int, you can have the number of students inside the student class. You can have the static variable, and then you can keep incrementing it, you get the number of students. So these are the scenarios where static variable comes to rescue, okay. Now one more thing, how the static variable initialization happens. Let's say I like duck count, maybe I put logic in some other place, okay. Now let's see the player class, or let's see the player class, or let's see this duck class only. Now here I did not specify the duck count, okay, and even in the constructor I did not put anything. Now what would be the value it prints? Let's see, you get the 0. So you did not initialize it, you just declared the variable, but you did not initialize it. But when I call duck count, it is giving you the 0. How that happens? We all know, right? Whenever you create an object in the constructor, default constructor, it will assign you a default values for all the instance variables. Like for integer, it assigns 0. For reference variables, it assigns null, something like that, right? The same case for static variables as well. It gets its default values, okay? That default values comes when you load up during the class loading, okay? So when class gets loaded, JVM loads the class duck class, and as soon as it, like I'm not talking about the object, I'm talking about the class. When JVM loads the class, then it will see what are all the instance static variables, and it will initialize the values for the static variables. Now but for the instance variables, you get defaults when you create an object, okay. So you understood that static variables also gets default values similar to the instance variables, but JVM does that for you. When you load a class, JVM assigns default values for the static variables, okay. And now you might get a doubt that when JVM loads the class into the memory. So class loading will, when you are loading a class, means you are actually using the class. You might be using the object, you might be using the static variables, you might be using the non-static methods. Now let's say you have this song class, okay. I'll declare some static count. Now static int count, okay. Now when you use this song class, okay, let's say you might be using something like that song.count of, you might like when you might try to use the static variable, then this is the one of the case where you use this song class, right? Song. Now one more thing is you might want to invoke this playoff method. Okay, you are invoking a non-static method. That is one more use case where you invoke the, where you need the song class, right? And one more thing is you might be invoking the static method as well, like let's say song.print random string of. So these are the three and when you want to use a non-static variable, instance variable as well. So there are four use cases when you use an instance variable, or when you use a static variable, when you use a non-static method, or when you use a static method. Okay, these are the use cases where you actually use the song class. Now when you when at least one of these cases happens, then the song class will be loaded into the memory. Java loads the class. These are the four use cases during which Java loads the class into the memory. Now if no one is using this method, okay, the methods that are present in the inside the song class or song object, or if no one is using the variables that are declared inside the song class or song object, if no one is creating objects, or no one, like one thing is if someone is creating the song object, or if someone is using the static variable or static method, then you will get a requirement for the song class. Then those cases only Java will load class into the memory. Otherwise, what is the need? Like let's say there is a song class, but no one is creating objects for that, and you have, let's say you have static variables declared inside it, static variables and static methods, and no one is even using the static variables and static methods. Then what's the point of loading the song class into the memory? No use, right? If there is a requirement, then only you will load it. If these three cases happen, if someone invokes song.static variable, if someone invokes song.print random string of, or if someone is creating object for song class, then Java loads the class into the memory, and during the class loading, it will assign the variables, default values for the static variables. Okay. So Java static variables gets an initialization during the class loading. Okay. Yeah. Static variables gets loaded. And one more thing, you can safely assume that now you might get a doubt, right? So static int count you have, or we go to the duck object. Okay, you have private static duck count, and you have some static method. I'll put some static method. Okay, public, since this is a private method, right? I'll put something like that, private int get duck count of, and then I'll give this return this dot duck count of, get this dot duck count. Okay. Now instead of this is a private variable, let's say you're calling duck dot get duck count of. Okay, this is the use case, duck dot, yeah, this is a static method. Duck dot, yeah, return duck count. Okay, so let's say this is a, now let us assume I'm putting this logic in another class. Okay, main, if I'm putting this logic, okay, yeah, I put this logic here inside the main instead of the duck. Now here I can't directly get the duck count. Okay, duck dot duck count of, because the duck count is a private variable, right? It's a duck count, duck dot duck count is a private variable, right? This is a private variable. Then the only way to get the duck count is duck dot get duck count of. This is a static method. Okay, now let's suppose you don't have these objects as well. So the only requirement that I see for the duck object is someone is invoking a static method. Now you might get a doubt, what is the order of initialization? And I said that whenever there are three cases in which a class gets loaded into the memory. First, you invoke a static variable directly, you invoke a static method, or you create an object. When you create an object, when you create an object actually, then static, when you create an object, instance variables gets initialized, okay? But let's suppose here let's suppose you are invoking a static method duck.get duck count of, and by the time I call this get duck count of, this duck count should have been initialized to 0, else this will throw error, right? So what is the order that static variables gets initialized? So whenever you are loading the class, okay, like the first thing that happens is Java variables, static variables gets initialized, okay? Static variables gets initialized. That's the first and foremost thing. You can safely assume that before you invoke any static method or before you create any object, these static variables will be initialized for sure. You will not get any error, because in this particular case, you might assume that this is the requirement, only requirement I can see for the duck class, and when you call this duck.get duck count of, as you said, the class will get loaded. But the variable initialization, would it happen even before this method invocation or after this method invocation? It happens even before this method invocation. So you can safely assume that before anyone uses static variables, be from static methods or directly, you can assume that these values would have been already initialized. That is, the initialization is the first thing. Static variable initialization is the first thing that happens, okay? Now here we all know, right, even for the instance variable, the default values that gets assigned at 0. But let's say I want the duck count to start from 2, okay? Then I have to change this initialization. I should not, like my default value should not be 0. I should have default value as 2. If I put something like that, okay, duck count equal to 2, then this will not work, because now here I am calling duck.get duck count of. I did not create any object. Whatever this duck count equal to 2, I put it in the constructor, and this constructor gets invoked only when you try to create an object. But if I try to use the static method can be used even before creating the duck object, right? So ideally, since I want to initialize this value as 2, then this will get done only when you create an object. Even before creating objects, if I do this duck count of, it will return 0, okay? It will not give 2, it will return 0. But ideally I want my value to start from 2, right? So in this case, to avoid these situations, if you want to initialize static variable values, then one thing you have to do is you have to declare the static block, okay? This is the static block. Inside the static block, you can put 2. Okay. Now, what happens is, static block is the first thing that gets loaded. When a class loaded, first thing that gets executed is this static block. Inside the static block, you can put default values, or you can initialize the static variables. And along with your logic, what Java does is, let's say you have one more static variable, okay, and you did not put any specific implementation for that, then Java takes care of that. Private static, if you put something test, then Java takes care of initializing this value. So you can compare static block with the constructor, okay? So what is the role of constructor? Constructor, it will assign the default values for the instance variables, and if you want your own values for the instance variables, you can put that logic, okay? And whatever variables you assign the values, those values will be taken care by Java. Let's say size will be 2, and if you have another instance variable for that, like private int count, so for size you are assigning 2, but for count you did not specify anything for count, then Java takes care of assigning 0 as the count. The same thing, whatever logic you have put in the constructor, how the constructor works, static block also works the same way. You can assign some values for the static variables, and the remaining variables Java takes care of it, okay? So static block is the first thing that gets invoked when you load the class. So, and the class loading happens when you invoke the static variables, or when you invoke the static methods, or when you create an object. Now, even before you can safely assume that even before you use the static variables inside the static methods or here, then you can safely assume that those got initialized. Okay, and here you can say, like, now I have put duck count as 2, right? Now it will give 2 here, because static block is the block that gets executed for the first time. Okay, so to just recap the things what we have discussed, static variables are the class variables. So this is the shared variable. It doesn't lie inside the object, and this copy can be shared by all the objects. Okay, now static variables gets initialized during the class loading, and class loading happens when there is a requirement for a class. When you say the requirement, someone is invoking static variables, or someone is invoking static methods, or someone is creating the objects. Okay, so during that class loading, static variables gets initialized, and static variables gets initialized even before someone uses the static variable. Like, now if I try directly call duck count, even before that, as soon as class loading happens, the first thing that happens is it assigns the default values for the static variables, or if you have static block declared, that is the first thing that gets done. Suppose that if I am invoking the static method, then this will run after initializing the static block. If there is no static block, Java jumps in and it will assign the default values. Okay, so we understood it, right, how the static variables works. Hope you understood it. Thank you. In the coming video, we will discuss about the final keyword in Java. Okay.